Hello everyone, welcome to C1 Simultaneous Equations. This is a skills video, so we're going to be expanding on what you know from GCSE in terms of simultaneous equations, and kind of showing you what simultaneous equations really means in terms of graphs, etc. You should be following along with your packs. You can do the first example with me, maybe second with me, and then pause it on the third example, try it yourself, pause it for the fourth example, try it yourself, and then check to see if you're right and bring in those packs at the beginning of each week. Okay, so here we've got two equations, 1 and 2. Okay, 1 and 2. And these aren't in the normal fashion that you would see them in. Normally, for GCSE, you would rearrange these, wouldn't you? You'd have 3x minus 4y equals minus 7, and you would have x plus 2y equals 3, and you would use what's called elimination. So you would times number 2 by 3, and you would say, well, that's 3x plus 6y equals 9, and you'd bring back your old equation and you'd subtract, and you'd get your 10y equals 9 minus 7, so that's 16. So therefore y equals 16 over 10, which is 8 over 5. Fair enough, but what does that really mean? And can we come up with a kind of more efficient way of doing it? Well, what it means, what these things relate to, is that this 3x minus 4y plus 7z, well, that is actually a graph. So if we put that in, that's here. If we put this second one in, that's here. So when we're talking about simultaneous equations, we're actually talking about two graphs intersecting, so the coordinates of where two graphs intersect, because anything can be represented by a graph. So we not only need to know the y coordinate, that makes sense, but if we were to hone in on that point, that central point where they cross, just looking at the y value isn't good enough, is it? We need to know the x value as well. We need a set of coordinates. That's why for simultaneous equations, I should always expect however many variables there are. So in this case, there's x and y. There are two variables. I expect two equations. So we could find that second equation, that second variable, couldn't we? If we know y is 8 over 5, and we know x plus 2y equals 3, so x must equal 3 minus 2y, 3 minus 2 lots of 8 over 5, and you get your answer. We'd whack it into our coordinate brackets, fair enough. But though that GCSE method is helpful, I want us to try and get away from that. I want us to try and actually go for this method of substitution instead, okay? Because most problems will be using this method. So what we're going to do is, rather than timesing this second equation by 3, we're going to just see that x, when you're in simultaneous equations, these two curves, the x and y are the same. So therefore it makes perfect sense that this x and this y are the same at that point as this x and this y. So what we can do, we can substitute that x into this one. So we have 3x minus 4y plus 7 equals 0. We can then substitute this x in by rearranging, because we know that x equals 3 minus 2y at the point of intersection of these two curves. So therefore, we can sub this whole thing into there. So this is 3 lots of 3 minus 2y minus 4y plus 7 equals 0. And you see we've eliminated x. We've done your elimination method, but we've kind of not had to times everything and make everything the same and then subtract it. So now I can multiply out. So 3 times 3, 9, minus 2 times 3, that's 6y, minus 4y plus 7 equals 0. So I get 9 plus 7 is 16, equals 10y, just moving it over, so y equals 8 over 5 like before. But we also need, remember, an x equals. X equals 3 minus 2y, which remember came from here, and y was 8 over 5. So x equals 3 minus 16 over 5. That's 3 is the same as 15 over 5. So therefore we get minus 1 over 5 is our x value. But let's not leave it like that. Let's whack it in coordinate brackets, because remember we are referring to a coordinate. And that's their point of intersection, and that's the problem solved. Let's look at example 2 then, another example of where simultaneous equations come in. Here we've got a curve. This is an exam problem. So we've got a curve of y equals 10x minus x squared minus 8. And here we've got a straight line, y equals 10 minus x. This is a substitution problem if we're trying to find, for part A, calculate the coordinates of A and the coordinates of B. That is the points where the x and y value of these two curves are the same. So therefore, since we know y equals 10x minus x squared minus 8, and we know y equals 10 minus x, and these y values are the same at this particular point and this particular point, we can sub number 2 into number 1. So we have, therefore, y, which is actually 10 minus x, is also the same as 10x minus x squared minus 8. Now we can start solving this thing by moving everything over to the left. So really, simultaneous equations aren't that difficult, except for if your algebra is weak. So that's why we stress algebra needs to be strong in AS level. So this is going over there. The 10x is going over there, so that's minus 11x. And then we've got the 10 plus 8, so that's 18 is 0. Wow, how can we find the coordinates here? Maybe we can factorize it. So 2 and 9 I reckon will work, minus and minus. Therefore we get x is 9, we get x is 2, but we're looking for coordinates. So we need those y values. So many people miss the y values, and that's a really important facet to what I'm saying here. So if x is 2, we know if we shove that into one of those equations, it doesn't matter which equation we use, because remember, x and y are the same in both of these equations because they cross at the same point. So y must equal 10 minus x, which is 2, so therefore y is 8. And for this x equals 9, put that in there as well, 10 minus 9, y equals 1. But I wouldn't leave it like that. I'd give it a name, so we know that A is when x is 2 and y is 8, and B when x is 9 and y is 1. And we're finished. So remember, pause the tape now, try this yourself, and then play it back and make sure you've got it right. So pause it. Okay, so what two items do we have here? Well, let's see. We have, hopefully we recognize this as a straight line, but it just looks a bit, doesn't quite look like our normal y equals mx plus c, but we can definitely make it look like that. So that's a line. Here we've got, you guessed it, a circle. And let's just see what happens when this line and circle interact. So you can see graphically that they cross at 2 points. So I'm looking for 2 coordinates of intersection. And that's what simultaneous equations are. That's the key thing to remember. They are 2 graphs crossing, or not crossing if there aren't any solutions, but we'll assume that there are solutions, and we need to remove one of the variables, eliminate one of the variables via substitution. So we've got our x plus 1 squared plus y minus 2 squared equals 4. We also have 2x minus y minus 1 equals minus 4, but that's not very nice. I reckon we should make y, doesn't matter which one we make, y or x the subject, but for ease I'm going to make y the subject so I don't have to divide anything. So if I move the y over, I get 2x minus 1, bring the minus 4 over, so that's plus 4 equals our y. So y equals 2x plus 3. And now we can sub that into our circle equation, because remember x and y are the same at that particular point. So we've got x plus 1 squared plus our new y value, which is 2x plus 3. That's that y value here. Minus the 2 still, squared equals 4. So notice all y's have gone. Everything's one variable. And we can solve this, can't we? So this is x plus 1 squared plus 2x plus 3 minus 2, so that's plus 1 squared equals 4. So expand that out, x squared plus 2x plus 1 plus 4x squared plus 4x plus 1 equals 4. Now we can just finally solve this, so that's 5x squared. We've got our 2x plus 4x, so that's plus 6x. And we've got our 1 plus 1, and also we've got that 4 over here, so I'll move that over to the right. So that would be minus 2 equals 0. Does it look like I can solve it? You know, if it doesn't look like you can factorize it straight away, not sure, then I'll just go for the quadratic formula, which as we know is x equals minus b plus minus square root b squared minus 4ac over 2a. I'm just going to assume you know that from now on. So x would be minus 6 plus or minus 6 squared, 36, minus 4, 5, minus 2, all over our 2a, which is 10. And I can leave you to solve that. So I want to see what x value you get. And of course, you then have to shove that into your y value. And you know the simplest version of y is our 2x plus 3. And so you can shove that back in. Okay? And remember, we should end up, because this is a plus or minus, with two sets of coordinates. So pause it again and make sure you know and try and figure out what they are. Remember you could also use your silver calculators for this if it's like a horrible one, but generally, especially for C1, we'll make sure we know how to use that quadratic formula. But what you should get is a point P, nasty numbers, so minus 3 plus root 19 over 5, and your y value 9 plus 2 root 19 over 5, and another, we'll call it Q, so that's minus 3 minus root 19 over 5, and 9 minus 2 root 19 over 5, and we're done.